So as promised in the last video, I did a strip down of this AllStar Node. And the reason is because originally this used to have a horrible scream on the audio. It's not as bad now. And that was caused by the buck converter from 12 volts down to 5 volts. It's got a big inductor on it, and that causes all sorts of radiation of noise, and it was just awful. Mine is different to lots of the ones that you see on other people's nodes. Somehow, a lot of people use the Baofeng BF888 UHF analog radio inside, because they're only about £10. They take the guts out. And I wanted it on 2 meters. And I didn't have any set that I wanted to give up, except this one. That one, the BJ218, as you can see. And so what I've done is I've designed this. So this radio can be used as a normal radio, i.e. you can talk on it by just plugging a microphone in. Or, because of the way I've made the interface leads as well, you can plug it in straight jack into a PC, and you can use it as a packet radio, BBS, you can use it for APRS, and also in this case, because of where the plugs are on the speaker on the back and the microphone socket on the front with that lead in it, that means that you can use this also for AllStar Node as well. So here we are. So what I'm going to do is going to switch this on, first of all, so you can see it. And then what I'm going to do is take it to pieces, just so you can see inside, as promised in the last video. I've already done this once. Unfortunately, it's a bit shaky, down, and the video wasn't real, so I thought, right, I will re-video this. That's the idea. So when this comes on, and when this comes on, with Baofeng in hand, there you go. Voila. So here we have the radio. I'm just going to finish off taking the screws out, turn it over, and yes, it's going to have to focus. I got this on manual focus because I'm sick of these things keep focusing on their own every time they want to do something. Your knots of screws on the bottom of this here. I'll just explain in a second. Get me dirty grey hand out the window, David. Yes, that's the way. Okay, so just taking the feed off here. Yeah, you can see lots of these, and these are all 2.5 or 2mm plastic nylon screws. These are just securing the fan on the inside. You'll see in a second. What I need to do is just disconnect the microphone and the earpiece. It says UHF antenna, but that's the old one. So here we go. So, and you see the insides. So there we go. What I've done is it's still a bit. What the heck is this here? Janky. Don't know where that came from. Okay, so you're going, why is the little blue, what is this in the center? All right, so here we go. This is the Raspberry Pi 3, and then you have the linear voltage converter. Basically, it's an LM317, and yes, I know people are going to say they only do 1 amp, 1.5 amp, and this takes, yes, I know, that's why I've put a 2N3055. Let's tip it over so you can see it. A 2N3055, TIP 3055 as a bypass, and there's a shunting resistor there. Measure any over voltage current, and there's your LM317. And it came attached to this board, and I just thought, let's redesign it. It just means that all the components on just to adjust it and do overcurrent are already there. And in the center we have an Arduino Uno, or copy Arduino Uno, and this little board here, which is actually glued in. It's a bit still loose. There is a potentiometer on there, a multi-20 turn potentiometer. That is for getting the level right going into the analog input on here. And the idea of that is the radio, this baby was trying to get a COS, carrier on select. In other words, it's some kind of indication when it is actually received a signal and that it has been received and it has opened the squelch because its CTCSS tone matches what is in the radio and everything else. The radio then passes it on, or it passes on the audio and a indication to the sound card on here, this CM108, which I'm pointing at. That then tells, which goes through via the GPO port on there, which then tells the Raspberry Pi, hey, I have a signal, there's audio coming in from the radio. Ta-da. That's all it is. And what I wanted, and because this BJ218 doesn't have signals just to hand where you can just pick off a COS signal like you can with some radios. I mean, like on the BF 888, what they use in most of these nodes, some people have found you can just tap onto a resistor or whatever and get the output that you need. It seems to be on most radios. I mean, there are ways around that. You can actually do it by like a Vox kind of function. But anyway, so there we go. So I have the Uno inside just to detect the level, because I found that inside the circuit board for this BJ218, whilst I was probing around with an oscilloscope, firing up and actually looking to see what changes state when a valid signal is received and the CTCS is satisfied, what changes state and by how much. And then I found a signal which actually changes state by about 300 millivolts. It's not a lot. I mean, I could have amplified it, but you know, by the time you get discrete components and put them all together, you've just exceeded $5. And an Uno is less than $5. And the little components I have was knocking around in my spares box. He says spares box. I have 1,000. No, I have a few of them. So I'll just use an Uno. How many people like me, constructors, are actually going, oh, forget that. Why should I stop putting logic gates together and analog and doing this, when I can just use an Uno? Because an Uno is so cheap and everything's on there and it's programmable. And you don't even have to have the program. All you need to do is talk to ChatGPT. Do you know what ChatGPT in French means? It means cat. I farted. ChatGPT. GPT. Anyway, so I might edit that one out after. So that's what's inside here. As you can see, very simple. I have gone to a long length of actually having a central earth point and using screened cable for the audio, and actually trying to be clever there. What I'm going to have a Lancashire did do here. Anybody from Lancashire will know what a Lancashire did do is. So the CM108 USB sound card interface board. So yeah, it's based on the CM18, but anyone will do. It's got a transistor on there you can't see, and that transistor is for the PTT switching. So in other words, this sends a signal out from its GPIO port, which switches the transistor. So the transistor then switches the PTT on the radio in the correct state. And the reason why I have done it this way, and that is, if a fault occurred on this, you see, and the PTT on the radio switches from a level of a 1 or whatever, 5 or 12 or whatever voltage to 0 to actually do the PTT function to transmit. If there was a fault on this, then that line would drop and then the radio would go into transmit mode. So I didn't want to do that. So what I've done is the transistor is actually an inverter as well. So to go on PTT, it has to go to a 1. Now it has to be a very serious fault to actually go to a 1. Just anyway. what else I've done? Oh yes, because I'm using a linear power supply, these things generate heat. For example, I'm coming in at 12 volts from my 45 amp linear power supply, and I'm outputting at 5 volts, or just over 5 volts, 5.1. So where's the rest of the voltage going? That's round about 7 volts. Well, that's 7 volts plus the current that's been used by the Raspberry Pi, the interface, the Uno, and any other the circuitry around there. So that if you, for example, say if this was taking 200 milliamps and this was taking 1.2 milliamps, so that's 1.4 milliamp. There's LEDs on it. Call it 1.4 milliamp, 1.5 milliamp for argument's sake. So 1. Milliamp, amp. People throw these terms around as if they know what they're talking about. Amps. So 7 volts, 1.5 amps. That is 10.5 watts. V times I equals power. 10.5 watts of power that's going to be going as heat. Heat has got to go somewhere, so it's into this heat sink here, and it's cooled by a fan, which I've turned down the speed so it doesn't get too noisy. I mean, people say, well, why don't you just put a buck power supply in and be done with it? Well, I did, but I wanted to do it this way just because I can. And you've also noticed I've actually put correct sized cables to in case I want to take more current, just in case. But I'm not. 1.5 amps, or call that, at 7 volts, 10.5 watts is a lot of heat when you build it over time, and then when you put it in a small case as well, everything's going to get hot. This generates heat, that a lot of heat, that generates heat, that generates a bit of heat, this generates heat, all generates heat as well as that 10.5 watts. So you may also be generating a total of, I don't know, 15 watts, for example. That's a lot of heat to be going on constantly inside this little box. And if you've ever felt one of these nodes, they do get hot. That is why I put this heatsink and the fan on in there, to try and dissipate some of the heat. Yeah, I know it's just blowing around in a circle, but at least my case has ventilation holes at the bottom and the top. Unfortunately, just slightly next to the radio. But anyway, it does work, and my DC output from there is smooth, or smooth as can be. Here endeth the video, the showcase of what's inside here. Oh, you may notice this little board at the back, which is a bit, I glued it on ages ago, years ago. Besides AllStar Link, oh, I don't know what I put that on there for. Anyway, besides AllStar Link itself being able to adjust the volume of the transmit and the received audio using software, the output from this radio was actually it was very large, and it was getting distorted. So what I've done is I've dropped it. I could actually go down a bit more in level as well. There's actually too much audio level coming out. So and now, because I'm not using the volume control on the radio, I'm using. So anyway, there's my volume control. That is the one that's changing the. And why can't I get that straight? There we go. Center of picture. So there you have it, peeps. There is a reset switch here. It's a push button, but it has an LED on it. When you press that, it shorts out 2 pins from pin on the Raspberry Pi, and there is a script in the Raspberry Pi to tell it that when you see this pin going to 0, start the shutdown sequence. So basically that is it's called a gentle shutdown of the Raspberry Pi, because these things do not like, especially if you run it from a micro SD card and it's down at the bottom here. You don't want that. I have a single LED, multicolored LED on here. I don't like the heartbeat lights that somebody people put on, and it's like obnoxious. It's bright blue, it's right there. No, so I have green for receiving a signal coming in either from the radio or from the internet. When it's a received signal is satisfied and it hits the COS, that goes to green. When it's not doing anything, it means it's not actually receiving anything. And when it goes to red, it means I picked it. I'm transmitting. I'm pressing the PTT. That's it. That's what's inside this radio. Well, thanks for watching. It's quite a long video, this is one. 12 minutes, 13 minutes just to tell you what's inside.